Okay, so we're going to continue with the power and exponent, so it's still 1-2. Okay, raise your hand if you know what the difference is between a power and an exponent. Or you think you do. Anyone think they know? What's the difference between a power and an exponent? Or is there a difference, or what do you think? Can you define one of them? Can you define one of them? Yes, thank you for volunteering.
Exponents is like when you multiply it by the same number.
Okay, exponent is multiplying by the same number. Okay, and what do you think a power is? Do you know? No? What do you think?
Oh, the power is like to the power of 2, saying if you're doing a long problem, like the gem problems, it would be the power of 2.
Good. So there's not like a huge difference really. They're just two different math words that mean almost the same thing. So exponents and powers are the same, right? Pretty much, that's what you guys are saying. And you're right. It's just one of those words in the English language that can mean the same thing. Okay? So the first example I want you to write down starts with this, a -2 to the 5th. Notice the -2 to the -2 is in parentheses. And it means -2 times -2 times -2, 5 times, right?
Yeah.
And the answer is -32. So write that down, and then we'll talk about why it's like that. Okay, so raise your hand if you think you know why the answer is -32 as opposed to +32. Why you know it's negative instead of positive. Anyone know? Or they think they know? Tell me your name again. Cody, what do you think?
Because all the numbers are negative.
So he says all the numbers are negative, so it must be negative. You're not right, but I'm going to give you a ticket anyway. Someone actually know why that's not correct? Or they know why it's negative? Ooh, lots of you know now, huh? What's your name again?
Mason.
Mason, go.
Is it because after you multiply one, then it changes into positive, and then after that it becomes negative and positive?
I kind of see what you're saying, but we're not quite there yet. Look at the exponent. That is a hint. You know?
The exponent's positive.
Not the exponent's positive. Something going on, though. There's something going on. Justin knows. He's dying to tell me. What is it, Justin?
It's an odd number.
It's an odd number. Bingo. You got it. Okay, so if the exponent is an odd number, it's going to be negative every time.
Even if the one inside is positive?
No. You have to start with a negative number. Okay? So, the exponent is 5. That's odd. If it was a 4, it would be a positive because 2 negatives, when you multiply them, cancel each other out, don't they? Negative times a negative is a positive. Remember this? Yes. So if you have something in parentheses that's negative and the exponent is an odd number, you're always going to get a negative answer. Here's another one to write down. This is a fraction. This is 1/3 to the 4th power, and that means in expanded form that is 1/3 times 1/3 times 1/3 times 1/3. And that should equal 1/81. So the 1 is going to stay 1 because 1 times 1 times 1 times 1 is 1. The 3 we have to multiply out. 3 times 3 times 3 times 3. if it's not a 1 on the top, like you'll see in your homework later, like say this was a 2, that would change. It would be 2 times 2 times 2 times 2. Okay, so if it's not a 1, it's going to change. So whatever you do to the top here, to the fourth, you do that down here. Okay, numerator, denominator, you have to still expand them out and multiply them. Okay, here's another one. This one has a star by it. I put a star by it because this is a really good quiz or test question. And you'll notice there's some interesting things, like there's a -1 all of a sudden there. See that -1? We're going to talk about that in a minute. If you think you might have an idea why it's like that, you can be thinking about it and raise your hand in a minute and we'll see if you're right. So this -2 to the fourth means that we take the -1, we multiply that by 2 to the fourth. So that's -1 times 2 times 2 times 2 times 2 equals -16. Now, it is kind of interesting because see this 4 is even, and I just got finished telling you if it was even, you'd get a positive, right? If it was odd, you'd get a negative. So this is even, but we got a negative. Raise your hand if you can tell me why. Claire?
Because we multiplied it by a negative number.
Why did we multiply it by -1?
Yeah.
Not sure on that one? Who thinks they know? What's your name again?
Connor.
Connor, why?
Is it because the negative counts as a 1?
It is. But why? How is that different than the first one? The very first problem we did. Can you see the difference? In the first problem up there, -2 to the fifth, and then this one, -2 to the fourth. What's the biggest difference you notice?
Well, that's a 5. Well, it's an even number now.
Okay, what's the other thing you notice?
It's not parentheses.
Good, parentheses. Parentheses make all the difference in the world, right? Remember when you're doing order of operations? Order of operations, you have to look at those parentheses. That's the very first thing we look at, right? Okay? So here we have no parenthesis. So that means the negative is on the outside. That's separate. But the 4 goes with the 2, right? This 4 does not go with the negative. Otherwise, this would have to be a positive 16. So if I put parentheses around the -2, it would be positive. Remove the parentheses, and now it's negative. Big difference, right? Questions?
Why is there a 1 there?
Why is there 1 there? Because this negative is like an imaginary -1, right?
That's what I thought.
Yes. Justin?
Shouldn't there be parentheses around 2 to the 4th power?
Right here?
Yeah.
Or right here? Oh, there doesn't need to be.
Oh, okay.
There doesn't need to be. Yeah. But I put it here because this is a good quiz or test question, and this always confuses people. They always end up over here because they think, oh, even, positive. So just remember, parentheses are important. Okay. Here's a little chart I want you guys to copy down. This is the expanded form. This is with exponents, and this is if we solve it. Evaluate means solve, so I wrote that for you. So write these 4 different problems out. You can see I put another fraction in there so you get practice with that. If I ask you to evaluate or solve, I'm going to let you use a calculator. Unless it's just like 2 squared or something. So sometimes we'll give you problems like this where it's expanded and you have to go just to here to write it with an exponent. Sometimes you get it where it has the exponent and we'll say write it in expanded form, right? So you have to kind of know how to go back and forth. And then sometimes we'll ask you to evaluate or solve. In the directions, if it says just expand, expand. But don't solve it unless it says to. That's extra work for you that you don't have to do, right? So if it says solve or evaluate, then you can get the answer with your calculator. Okay guys, so to summarize what we looked at for this very first rule, remember there's 8 of these exponent rules, but just to summarize this one, there's an explanation in words in case you're asked to explain something in words, and you can copy this down. It's a summary. A product meaning multiply, right? Product is a word in math that means multiply. Of repeated factors can be expressed as a power using an exponent and base. Here's a little example for you. So factors are the 4s, right? It's the base and the exponent. Are there any questions on the summary or what it means? You got this? So on a test, if you're asked to explain what you did here, you could use these words or you could put this in your own words, right? That's something we'll practice in this class. So all of these examples and the previous notes are going to help you to do the homework, which I'm going to explain. So you don't want to put your notes away because you will have class time to do your homework today. But I will show you and explain what it looks like. So your homework today is going to be, it's a half sheet of paper because we still don't have all the books in yet, but these questions come right out of your book. Okay, so on the half sheet, it basically says at the top what the title is and it has the page number and all this. This is just from your book. So you're going to do this on binder paper, but you don't need to rewrite what the assignment is on the binder paper because you're just going to staple this when you get your math book. Yeah, it's that workbook like that.
When do we get it?
I think Friday. Cross my fingers. So when you get your binder paper out in a minute, you don't have to rewrite this. Just put your name and period on that binder paper. This will be stapled to the top. Question?
How many problems are there?
10, no more than 10. Yeah.
Do we use a notebook or regular?
Regular binder paper for this. Yes.
We get the rest of class to do this, right?
You get the rest of class, so you can work all the way until I say stop.
Alright.
Okay, so let me explain this while it's still recording so the people that are absent know what to do. Okay? We all got the notes? Yes?
Yeah.
Good? Okay. So on this paper, there's a couple questions, and I noticed right away that the first 4 questions have a lot of words in it. You all notice that? Mm-hmm. And be honest, raise your hand if when you see words like this you give up. right? I know what you do. Okay? But that's let's see if we put them first, so that last is the easier things, right? Right? These are all the easier things. But the first four we're going to go over really quick. Okay? If you want to make notes on your paper as I'm going over them, that's fine, and then I'll pass this to you. But if you think you're going to forget, you can write number 16 and write down what I say. So number 16 says, give an example of a repeating decimal where 2 digits repeat. Raise your hand if you can tell me a repeating decimal where 2 digits repeat. There's a bunch of them in your notes. Tegan? 3.141414. Good. 3.14, and you could put a bar, that line over the 1-4. That would be repeating, right? 2 digits. 1 and 4 keep repeating. Explain why your number is rational. Why would you say it's rational? Cody? Because the number repeats? That would work. Right? Because we just did that other paper that said what makes them rational, right? It repeats or it ends, right? So you already have an answer. You can change yours if you want, but there's one. Number 17 says, explain why any rational number is either terminating or repeating decimal. What does terminating mean?
Destroy.
End, like the Terminator. So why is a rational number why does it either end or why does it repeat? Now, there's a lot of different answers here. You can look in your notebook at the first day or second day we did this chart, and you can be like, oh, okay, these are rational. They're integer, whole number. You can make some observations about that and just write that down. Okay? And then 18, based on what you know about 0.1, 0.1 repeating, 0.13 and 0.13 repeating when written as fractions. First of all, let's look at this. What is 0.1 as a fraction? Do you guys know? What is it? You can say it. 1/10. Good. What is 0.1 repeating? 1/9. Good. What is 0.13? 1300ths. What is 0.13 repeating? 1399. Do you notice there's always 9s happening? So what do you think is going to happen here when it says make a prediction about this one?
999.
Ah, good. You have an answer. 19. Write 2 decimals. 2 decimals. You can write 2 decimals. 1 repeating and 1 terminating with values between 0 and 1. So these are all small, like 0.1, 0.2, 0.3, right? Then write an inequality. Inequality. Inequalities look like this. Do you remember? In elementary school they had alligators with them.
Yeah.
Remember those? That shows the relationship between your 2 decimals. So you need to pick 2 decimals. 1's repeating, 1's terminating, between 0 and 1, and write an inequality. This is very simple, but all these words make it seem difficult, don't they? Then here, these ones right here, it says write using exponents. So do you need to solve these? No. How about these? Should we solve these?
Yeah.
Clearly, we should solve these.
We shouldn't.
10 problems on binder paper. Some of you will finish in class. If you finish in class, do not turn them in. We're not collecting them till Friday. You can just staple them. There's a stapler in the back counter, okay, or the back side counter. Staple them to the top. Put them in your binder, and then sit down and look around the room. Remember, there'll be a short quiz for tickets at the end. Questions, Justin?
Can we do it on that piece of paper?
Don't do it on this paper. Do it on binder paper, please.
Or if we write small?
No. Binder paper. Yes. The quiz is not for a grade, it's for fun. Any other questions? That's it?